Hello and welcome back. I am Basu Ratnayaka and today we are starting an exciting new video series on building an anime recommendation system with machine learning. This series will cover all aspects of the project, including but not only limited to architecture, machine learning, database integration, APIs, and many more. Before we dive into the project, I want to share a little backstory. The inspiration for this project came to me during the long weekend. I actually love watching anime in my leisure time. And as someone who enjoys both tech and anime, I thought, why not merge those two passions together? And as the saying goes, do what you love and you'll never work a day in your life. So, this is a fun way for me to explore that. A quick reminder, if you haven't already subscribed, hit that subscription button to stay tuned for upcoming videos, where we'll dive deeper into more exciting projects and topics. Now, before we dive into machine learning or databases, let's make sure we have a solid foundation for the project. As you may know, if you want to build a robust system, you need to think of it like building a monument. There's a quote I love from the movie Robin Hood by Russell Crowe. If you want to build a cathedral, you need to lay the foundation brick by brick. That's exactly what we are doing here today, starting with the fundamental layers and then moving on to the functionality. So let's discuss our foundation. We'll start with the repository and the unit of work patterns, which are key for separating concerns, managing our database, and ensuring our code is testable and easy to maintain. The repository pattern, which abstracts data and the data access logic instead of directly interacting with the database. We create repositories that provide a clean interface for data operations, keeping our code organized. Next, we have the unit of work pattern. This ensures that all data operations happen within a single transaction. It helps group multiple changes to the database in a way that either all succeed or all fail, providing consistency to our database. Now that we have a clear idea of our foundation with the repository and unit of work patterns, let's discuss the material we are going to use to build our foundation and subsequently our monument. In this case, the material refers to our programming language and the development environment. We'll be using .NET 8, one of the most versatile and powerful frameworks available, along with Visual Studio 2022, one of the most robust IDEs. This combination will help us bring our anime recommendation system to life. Alright, let's get this show on the road and start building the structure of our project. Just like laying the foundation for a building, organizing our project into clear and manageable layers is key. We'll set up separate layers for infrastructure, domain, application, presentation, and test, each with its own responsibility. This structure will not only keep our code clean and scalable, but will also make integrating features like machine learning much smoother as we move on forward. So, we'll start by creating a blank project. Okay, so type blank here, select the bank solution. Yeah, we'll give this a cool name like AnyRec. AnyRec meaning anime recommendation. I think it's okay, but any suggestions on this is highly appreciated. The name. So, okay, we have the solution. Next, we'll implement this layer by layer by adding projects. So we'll start with the domain layer. This domain layer is purely focused on the business problem and should be free from concerns related to data access, user interfaces, or application specific logic. So we'll add a class library. We'll call this anyrec.domain. Okay, so .NET 8. Okay, we'll get rid of this class here because we'll be implementing these things later. So this will basically house the interfaces and our entities. We have the interfaces, then the entities. Okay, entities here. Now next we'll add the application layer. Application layer is basically responsible for handling application workflows, validating input, converting data between the domain entities and the DTOs to be used by the presentation layer. DTOs in the sense, meaning data transfer objects, because sometimes we may not need the entire entity to be presented to the presentation layer. So we have to change it a bit. So in order for us to do that, DTOs are a good option. So like this. This will also be a class library and application. Okay. Next one would be the infrastructure layer. Infrastructure layer is responsible for providing concrete implementation for the repository interfaces defined in the domain layer and handle interactions with the database, file systems, and third-party services. These repositories that I said earlier are basically the interfaces we will be creating inside the domain to be implemented inside the infrastructure layer. So create this. We'll call this infrastructure. Okay. Okay. So yeah. Infrastructure will have a database context which will reside in the data folder, and obviously the repositories and the unit of work implementation. Okay. Unit of work. Okay. So now we have the infrastructure domain. I forgot about adding the necessary folders to the application layer. We'll add them as well now. So the application layer will have the DTOs that I explained earlier, DTOs, and the services which will utilize those DTOs, services, and the interfaces. Okay. Now we have those things. Now we need the presentation layer. Presentation layer is basically a web API, web application, or a desktop applications, or any other user interface that the user can interact with, and is responsible for handling user input, displaying data, and calling the application layer to process certain requests that are received to it. So we'll add a new project. For now, we'll make this a .NET Core application. Okay, we'll call this embark. We'll keep this blank project for now because we'll be adding the functionality to it later. Yeah, this is creating it. So we have our presentation layer. Next, we need another layer. This is basically will be responsible for testing each layer. So we'll create an X unit. We'll explain how we are going to use test later on. So we'll just create the skeleton of this test. Okay. So we have any rec. We'll get rid of this sample unit test. Okay. Now we need another layer for our machine learning. This would also be a class library. This machine learning layer will handle the machine learning models and will integrate into the application layer. So we'll also discuss more about it later. So for now, we'll add the skeleton ML. Okay, we'll get rid of the sample class. Okay, now we have the core essential layers that we need. We may also need to add another layer for background tasks, like collecting data, logging stuff, web scraping, and everything. We'll discuss about this later as well. So we'll call this AnyRec background services. Yeah, I've been saying later quite a lot today. I mean, it will be easier to explain it layer by layer. Otherwise, it will be a little bit, a daunting task. Okay, so now we have the initial skeleton of our project. Before we proceed forward, let's understand in a nutshell how each layer interacts with each other. A request is received by the presentation layer, in this case our web application, then it's passed down to the application layer. This layer handles the business logic and interacts with both the domain and the infrastructure layers to manage data. This setup ensures a clean separation of concerns, making it easier to manage, test, and scale the application. So we'll start by implementing each layer. So we'll start with the domain layer. We'll start with the entities. This is basically the core items of the project, like any users, channels, and so on and so forth. For now, we'll keep it simple because we just want to create the skeleton, the initial skeleton. So this would be any public. We'll give this what do you call the ID field. Okay. Then we'll let the name do this as well. So string. Keep this simple. So the next one we would need a users for the system to use, right? So we'll call this user. Sorry. User. Okay. Int ID. For now, we'll just keep the ID. Later on, we'll add more fields to this. The next one would be the genre, like history, sci-fi, mystery, and all of those things. So this one will add an ID and a name. What type of this thing? So ID. So string name. So yeah. So each anime will have multiple genres to it. Like if you take for example Naruto, will have action, history, a little bit of sci-fi as well. So we'll add like this. We call this anime genre because it's a combination of both. Okay. In order to uniquely reference this anime genre, we'll add an ID field to this as well. Next one would be anime. We'll be just referencing the ID here. Then obviously the genre. Okay. Genre ID. Okay. Next, a user can have multiple animes. So we'll call this user anime. User name. We'll give this a unique ID as well. Call this ID. Then okay, anime ID. Then the respective user ID. Okay, the collection of the basic implementation of our entities are now done. Okay, but remember, we'll be expanding on these things later because for now we'll just create the basics of it. Next, we need the interfaces. Okay, this one will create the generic repository. Since we are using the repository pattern, instead of creating repositories for each entity, we'll create a generic repository. I mean, a repository to be utilized by each entity. Generic, yeah, start with I since this is interface. I mean, best practice, right? Generic repository. Okay, we'll make this an interface. Okay, so this would just house the interfaces for us when we are going to implement this interface. Since this is a generic repository, we'll use T like this. T in this case would be a class. So T is a class. And then we'll add the CRUD operations for this. Each CRUD operation will be an asynchronous task. So we'll name this task. entity. Yeah. Instead of making this create a sync, we'll just say add a sync and we'll pass on the entity. Yeah, this is really cool. Ah, yeah, Visual Studio is really good now. Okay. Next, we need to get an entity by its ID. So this one we get, we call it get by ID async. Get by ID async. So we'll pass in the ID. So now we have the basic CRUD operations. We'll add another field, I mean another interface method to get all the names of users. So we'll call this task by enumerable. We'll add the entity get all async. Okay. So the basic implementation of our generic repository is done. We'll implement this later on in the the infrastructure layer. So the next one would be the interface for the unit of work. Unit of work. We'll call this as unit of work as a unit of work. Okay. So this would basically be responsible for committing and handling our repositories and the database interactions. We'll call this thing. Okay. Next would house our generic repository. We'll implement the name repository. Call this any. Okay, we'll only have a get method because we'll be initializing it in the constructor when we implement this. Next would have a method to commit our transactions to the database. We'll call this complete async. Okay, we'll have another repository since we have the user this thing as well. Repository user. Yep. Okay, so the interfaces for the unit of work and the generic repository are now done. We'll now focus on the application layer. Okay, so we'll create a DTO because sometimes we may not need the entire, the entity. We may need application specific entities. For this, we use the data transfer objects, DTOs. We'll call this any DTO. Okay. So this should just have the ID. We'll later on expand on this. So prop and ID. Okay. So this is our first data transfer object. Next, we'll create the interfaces for our services. Okay, so this would be an interface. I service. We'll call this INE service to make things simpler. Okay, so this would be a public thing as well. We'll have the same methods that we had earlier, but we'll be utilizing the DTOs instead of the domain entities. We'll copy paste this thing here. It'll be easier that way. So services. On second thoughts, let's make this a generic service as well. T is a class. We'll rename this into iService, which will just be the interface for all the services that we're implementing. Okay, so in here, yeah, instead of the entities, as I said earlier, we'll be using the DTOs. Now we'll implement this interface class. Yeah, we'll call this anim service. Make this a public. Okay, public. a public class, implement the iService interface, iService, and this would have the any DTO. Okay, so this would have the implementation of the interface that we created earlier. We'll implement the interface. Okay, we have this address sync. Address sync is basically, yeah. Before we move on ahead with the implementation, we'll have our unit of work thing is declared here. So this would have unit of work. We'll implement, import it. Where is it? Yeah, I unit of work. Yeah, at the reference unit of work. Then we'll just creating the initialization of our unit of work. Remember, we have not yet implemented this unit of work, which will be implementing in the infrastructure layer. We're using the interface. So when we implement it, we can simply pass it on to this. So this would have unit of work. Okay, so this would be private data. I will name it like this. Unit of work. Then get rid of this. Say unit of work. Okay, now we have referenced the unit of work here. Now we'll create the add functionality for our any thing. So what we'll be doing here is we'll create any, it could be, yeah, any of the DTO name any, because we have to reference the entity. Then we'll add only the necessary parts that we got from the DTO. Then we need to add it. Then dot add, sorry, name repository. Name repository dot edit addressing, and then the name that we have here. Okay, then we need to commit this as well. Okay, now we need to commit this complete async. You see, this is where unit of work comes and makes our lives easier. Say for instance, we have to commit to two tables and one of them fails. We'll see it like this. Already. Unit of work dot user repository dot address sync. So we have to add to both the name repository and the user repository. But in the normal sense, this will already add it. But if one of them fails, our database will be inconsistent. But with this method, either they both go through or none of them go through. So it will be easier that way, right? So we'll commit this. Yeah, I think we need to change the interface here, because this will just be a task. It doesn't need to return anything, obviously. So delete the sync as well. Delete the sync, actually, do we need them to delete it based on entity? Just make it ID and implement this here. This doesn't need to return anything, just gets the ID, gets the job done. This thing also doesn't need to return anything, but we'll only get the ID, delete. Same thing here, nothing to return. Okay, so the same procedure for the rest of the what do you call services as well. So this would be a wait unit of work dot delete. So unit of work dot any first. The pass in the ID. We have to change here as well, I think. Unit of work. Yeah, I'll change it here as well. Delete. So let's pass in the ID and the ID. Right. Okay, then we'll commit it. Complete async. Get all also is the same thing. Get all basically will be returning. For now, we'll return a link code, but later on we'll use the enrollable. It will be easier that way. So this will be like this. Sorry. Then we'll select all of those things. Return. Sorry. It's really cool. Yeah, we'll select each of these things and then send it to the, this thing. So supply this. Names. Okay. Has to be selected anyway. So, what is this? Oh, yeah. Okay. We have the get by ID thing. Select get by ID thing. Same thing here as well. Name dot make this a same. Await. Then dot good. Return any dot select. Okay, we created this thing here. What is the problem? Okay. You have to select the ID, or we'll just say the update sync. These things will actually create beta implementation of this later, but for now we're using. Many update sync can be any update. Okay, so now we have created the service as well. This is, as you can see, is a very basic implementation of the service that we need. We didn't even select anything. We just return empty DTO here. We'll add more functionality to it later on. Next, we'll implement the infrastructure layer. So we'll be using entity framework later on. So for now, we'll just create a sample application DB context. Okay. This will be just a placeholder for our actual DB context. We'll now implement the generic repository. Generic repository. And we'll implement what we declared in the domain. So this would be a generic repository, implements the generic repository. Generic, yeah, okay. Be the T, where T is a class. Okay, so we'll implement these things. We'll just create a read-only application DB context here. Application DB context, and we'll call it context. We'll have a constructor called application DB context, and we'll call it get it context. Okay, so this is basically it. Okay, we'll also implement our unit of work this time. Unit of work. Okay, so this is the implementation. So we'll have a private DB context, and we'll have the same the application DB context that we used earlier. Application DB context, we call it context, and then we'll mention each repository that we need here. Say for instance, any repository. Okay, where is this? We even have to get here. Okay, we'll add another one. A generic repository user. Okay, so this is what we wanted. We'll later on initialize this as well. We'll reference our interface here, our unit of work, and we will have the method complete here. Where is it? Yeah. We already got that. Okay, good. Okay, so this is basically it. We can. Okay. So this is basically it. Yeah. I forgot. We'll initialize this thing inside the this thing. We'll say generic repository which we're using here. So we'll pass in base and the context, because later on when we actually implement entity framework, we will need this. CTR and CTR. No, for now we'll just keep this simple, and now to implement this will be easier. Okay, now that we have the initial implementation of our project, incorporating the repository and the unit of work patterns, along with our core domain entities, we have established a solid project skeleton. In our next video, we'll dive into integrating entity framework to enhance our database management and finalize the development of our core domain. Stay tuned as we continue to build on this foundation. If you found this video helpful, please give it a thumbs up and hit that subscribe button to stay updated with our latest content. If you have any questions or suggestions, feel free to drop them in the comments below. Thanks for watching and see you in the next video. Until then, keep coding and stay curious.